Topic 3, Day 3, special right triangles. Now there are two types of special right triangles that we're going to learn the patterns for today. The first is our 45, 45, 90 degree triangle, and the second is our 30, 60, 90 degree triangle. In order to use these patterns, first you have to make sure that your triangle actually has these angle measurements, right? So 45, 45, and 90, 45, 45, 90. What's really cool about 45, 45, 90 degree triangles is that if your legs are congruent, right here, if they're both the same, then you automatically know that you have a 45, 45, 90 degree triangle, because the only way for you to have those congruent side legs is to create that 45 degree angle. Okay, so if you have a 90 degree angle, you know that two sides are congruent, then you have to have a 45, 45, 90 degree triangle. Second is our 30, 60, 90 degree triangle, right? So you have a 90 degree angle, and then as long as you have one of these angle measurements, the 30 or the 60, since triangles always add up to 180 degrees, we know that the other angle will be the missing either 30 or 60 degree angle, okay? Once you know that it has a 45, 45, 90 or a 30, 60, 90 degree pattern, then we can use our guide triangles to solve for side lengths. A little bit of a side note, right? Almost every type of triangle that you can use special right triangle patterns for, you can also use either Pythagorean theorem or trigonometry. The idea is that when we get good at using our special right triangles, it can act as a shortcut. It should make things faster once we get good at identifying this pattern. So let's look at this first teacher example. What I can see right off the bat is that I do have a 90 degree angle and I have my two 45 degree angles, right? So what I'm going to do first is draw my guide triangle in the same orientation as the triangle that's given to me. So I'm going to imagine taking my 45, 45, 90 degree guide triangle, and then I'm just going to draw it like that. Maybe I can do that better. Close enough. And what I know about this guide triangle is here's my 90 degree angle. This is my A, square root of 2. Okay. And I'm going to look at each of my corresponding sides. So here 8 is going to be that A, D is equal to A, and E is equal to A root 2. And what we can do is write those equations. 8 equals A, D equals A, E equals A square root 2. And we're going to look for the equation that is either already solved, right? A number equals a letter, or the equation where there's only one variable, all right? In this case, our equation is solved for us already. 8 equals A. And what you'll see is the other two have two variables. So we're not able to solve those equations just yet. But since we know that 8 is equal to A, anywhere we see the letter A, we can replace it with the letter 8. So right below, D also equals 8. And then lastly, our hypotenuse, our longest side, is equal to 8 square root 2. So we know that D equals 8 and E equals 8 square root 2. And hopefully what you can recognize is even if we're able to I know that D has to be 8 because it's a 45, 45, 90 degree triangle and all of that, and then we use the Pythagorean theorem, we would have to go through the process of simplifying the radical in order to get 8 root 2. As opposed to here, the pattern already tells us it's going to be a root 2, so it should be faster once we get used to it. So here's our final answer. Student example number 1, try it on your own. And then teacher example number 2. Now I see that I have my 90-degree angle here, a 60-degree angle, and since all triangles have angles that add up to 180 degrees, if we do 90 plus 60, get 150. 180 minus 150 gives us 30. So we know that this angle right here has to be 30 degrees, which means it is a 30, 60, 90-degree triangle. Now what we're going to do is draw our guide triangle in a similar orientation. And I'm going to label my shortest side is A, my hypotenuse is 2A, and then my long leg is A square root 3. And then I'm going to go ahead and color coordinate my corresponding sides. And with that, I'm going to write their equations. K equals A. J equals A square root 3. And 24 equals 2A. My first two equations have two variables. And I don't know how to solve equations with that many variables just yet. But my third one, I can solve for A. Since 24 equals 2A, if I divide both sides by 2, A is equal to 12. Great. Now anywhere that I see an A, I can plug in 12, which means K is equal to 12 and J is equal to 12 square root 3. All right, so K equals 12, J equals 12 square root 3. Go ahead and try student example number 2 on your own. Now, the third teacher example, we can say, let's see, determine the value of the missing side. Here, we're given a right triangle, and it says that the two angles are congruent. Again, since we have all angles of a triangle have to add up to 180 degrees, and we have one that is 90 degrees, it leaves us with 90 degrees. In order for that 90 degrees that's left over to be split equally, we can divide it by 2, and we get 45. And so the only way for this configuration to work is for both of these angles to be 45-degree angles. So 45 plus 90 equals 180, where 45 is equal to 45. Okay? That means we can use our guide triangle. So I'm going to redraw that guide triangle just like that, and then label, here's my 90 degrees, A square root 2. And then again, color coordinate my corresponding sides, and then write my equations. So F equals A, G equals A, 15 equals A square root 2. And similarly, F and A, G and A, too many variables, I can't solve them yet. But my last one, 15 equals A square root 2, I can solve. So 15 equals A square root 2. I'm going to divide by square root 2 to both sides. A equals 15 over the square root of 2. Okay, so that is my value of F and my value of G. It's going to be 15 divided by the square root of 2, right? You can plug it into the calculator. You'll get some decimal value. That is what they're equal to. However, there is a mathematical convention that asks us not to leave square roots or radicals in the denominator, okay? So while 15 over the square root of 2, the value of that is correct, we have to go about simplifying this just a little bit more, all right? And this process is called rationalizing the denominator, rational. And all we're going to do is multiply by a useful form of 1 in order to get rid of the square root in the bottom. So 15 over the square root of 2, we can multiply that by the square root of 2 over the square root of 2. The reason why we can do that is because square root of 2 over the square root of 2 equals 1. So essentially, we're just multiplying 15 over root 2 times 1. We're not changing how big the number is. We're not changing the value, just the way that it looks. When we do that, we get 15 root 2 over the square root of 2 times the square root of 2 is just 2. So our final answer is that f is equal to 15 root 2 over 2, and g is equal to 15 root 2 over 2. And that is our final answer. All right? Try student example number 3 on your own.